Fernando Alonso had to physically let go of the steering wheel mid-corner at the Chinese Grand Prix because the vibration from Honda's new power unit was so violent it made the car undrivable. And that single terrifying moment is exactly why Adrian Newey has been forced to redesign Aston Martin's entire chassis philosophy rather than simply tuning a race car. This isn't just a reliability failure or a simple horsepower deficit, it is a fundamental clash between an engine manufacturer's unproven architecture and a legendary designer's packaging expectations, creating a blame game where neither side can fully escape responsibility for a season that has left them near the back of the Constructors' Championship. But here's the tension that nobody in the paddock wants to say out loud yet. Even if you completely erase the Honda engine from the equation and pretend it produces perfect power, the AMR26 is still measured at roughly 3.5 seconds off the fastest qualifying pace, which means we are staring at a problem that goes far deeper than just internal combustion vibrations. So is this truly a catastrophic engine failure that destroyed a good chassis concept? Or did Newey's team misjudge the correlation data so badly that even a perfect Honda unit wouldn't have saved their 2026 campaign? The numbers floating around the paddock tell a story of confusion rather than clarity. Estimates of the raw power deficit vary wildly depending on who you ask and what metric they are using as a baseline. Some sources cite a 60 horsepower thermal engine gap compared to Red Bull, while others whisper about a massive 136 horsepower energy recovery shortfall against Mercedes, and still others frame the total loss at 90 horsepower. Honda's own technical lead Shintaro Orihara refused to validate any of these specific figures when he spoke publicly, confirming only that performance in Barcelona was definitely poor compared to other manufacturers without offering a single digit to anchor the speculation. That silence is deafening. It creates doubt. It fuels rumors. Without a confirmed number from the factory, every horsepower claim remains a ghost story told by rival engineers trying to guess the size of the hole Aston Martin is digging itself out of. Adrian Newey himself admitted the structural consequence of this uncertainty. He stated plainly that he had to change the whole car because the Honda engine didn't fit as originally packaged, a concession that reveals how much the chassis design was compromised by real-world characteristics that differed from the theoretical data used during the initial design phase. Serious work on the current car didn't even begin until April 2025, leaving the team scrambling to adapt to an engine that shook the monocoque apart instead of propelling it forward. At one point early in the season, the reliability crisis was so acute that the team was reportedly down to its last 2 working hybrid batteries with absolutely no spares available, threatening their ability to even complete full race distances. Can a team develop performance when they are terrified of finishing a lap? That specific incident in Shanghai wasn't just a mechanical anomaly, it was a visceral demonstration of how the low-frequency oscillations from Honda's new internal combustion unit were transmitting through the entire chassis structure with enough force to compromise driver control at high load. When Alonso released his grip on the wheel mid-corner, he wasn't managing tire degradation or adjusting brake bias, he was reacting to a physical feedback loop so severe that holding onto the steering column became a safety risk rather than a driving input. ESPN and Motorsport. Calm have since explicitly framed this 2026 campaign as a crisis, citing that exact moment as the most alarming individual incident of the season because it crossed the line from competitive disadvantage into genuine danger. The vibration issue has been present since winter testing, but its escalation to the point where a 2-time world champion had to abandon vehicle control mid-apex suggests the problem isn't merely about damping or mounting stiffness. It points to a fundamental harmonic mismatch between the power unit's firing characteristics and the monocoque's natural frequency response. So what does that actually mean for the engineers trying to fix it? They aren't just chasing lap time anymore, they are chasing structural integrity. Every set of change aimed at extracting performance now carries the secondary burden of potentially amplifying or masking these destructive frequencies, which means the development path is no longer linear. You cannot simply add downforce or adjust gear ratios when the baseline mechanical platform is actively fighting against itself. This is why the team's stated goal for the second half of 2026 has shifted dramatically from fighting for wins to merely climbing back into a reliable midfield position, a far more modest ambition that acknowledges the depth of the hole they're in. The car isn't just slow, it's fundamentally compromised in ways that traditional aerodynamic or mechanical tuning cannot easily resolve without a complete architectural rethink. Batteries failed repeatedly, spares vanished entirely, mileage accumulation stopped. This reliability collapse prevented Aston Martin from gathering the continuous running data necessary to even begin meaningful performance development, creating a vicious cycle where the lack of track time made it impossible to validate fixes, which in turn led to more conservative running plans, which further starved the team of correlation data. Formula 1. Calm and the race has both noted that even isolating for the engine issues, the AMR26 remains approximately 3.5 seconds off the ultimate qualifying pace, a gap so large that it implicates chassis and correlation failures alongside the power unit problems. The race went further, explicitly rejecting the simple blame. the engine narrative by arguing that Aston Martin's car is as bad as Honda's engine, suggesting that the team's own simulation to track correlation breakdowns are contributing equally to the deficit. If the wind tunnel and CFD tools were accurately predicting real-world behavior, the team could at least optimize around the engine's limitations, but instead, they appear to be discovering fundamental aeromechanical mismatches only after the car hits the track, compounding the damage caused by the power unit's unreliability. The scale of the electrical challenge cannot be overstated either, as the 2026 regulations raised MGU K-power from 120 kW to 350 kW, a massive technical jump that Honda had to manage while simultaneously integrating an entirely new internal combustion architecture into a partnership that lacked years of shared operational history. This regulatory reset is precisely why manufacturer-to-manufacturer variance has been so extreme this season, but it also means Aston Martin struggles aren't happening in a vacuum of poor execution alone. They're occurring within a technological upheaval that has stretched every works team to its absolute limit. Well, the difference is that other manufacturers entered this cycle with established integration workflows, while Honda and Aston Martin were building their collaboration from scratch under the most complex power unit formula in the sport's history, making the vibration crisis not just a failure of engineering, but perhaps an inevitable consequence of attempting too much transformation simultaneously. Honda's revised power unit reportedly met internal targets before its Zandvoort debut, yet potential gains remain fiercely debated across different motorsport outlets. Some sources suggest the update could deliver 20 horsepower. Others claim the improvement might reach 50 horsepower. No single figure has been independently verified by multiple credible sources. This wide range itself reveals a deeper problem. 20 horsepower would barely dent the current performance deficit. The AMR26 would remain firmly stuck at the back. 50 horsepower would represent much more meaningful progress. Even that gain falls short of closing the gap completely. It wouldn't satisfy even the most optimistic thermal estimates. The larger energy recovery deficit would persist regardless. Credible outlets cannot agree on the upgrade's true impact. This disagreement shows how deep the information asymmetry runs. Every layer of coverage reflects this fundamental uncertainty. Aston Martin must plan development around unconfirmed projections. Engineering decisions rely on guesses rather than hard data. The team cannot validate improvements without reliable baselines. Each track test becomes an expensive experiment in hope. Upgrades arrive carrying enormous uncertainty about their effectiveness. Resources get spent chasing potentially illusory performance targets. Meanwhile, competitors operate with far greater informational clarity. They know exactly where their own deficits lie. Aston Martin navigates through fog while others use precision instruments. This structural disadvantage compounds the existing technical challenges. Recovery requires not just better parts, but better intelligence. Without confirmed numbers, optimism remains a calculated risk. Adrian Newey confirmed on August 3rd that Aston Martin is now in early research stages for the AMR27, working through big architectural decisions like where to position the engine in the wheelbase and how to orient the chassis relative to it. This forward-looking admission carries an implicit acknowledgement of what went wrong this year, because you only rethink fundamental packaging architecture when the current solution has proven structurally incompatible with its power source. He stated explicitly that the team had to change the whole car because the Honda engine didn't fit as originally planned, a phrase that sounds simple but represents months of wasted development time and compromised aerodynamic concepts. When a designer of Newey's caliber says an engine doesn't fit, he isn't talking about bolt patterns or clearance issues. He's describing a mismatch between the power unit's physical dimensions, cooling requirements, and vibration characteristics versus the aerodynamic and mechanical philosophy the chassis was supposed to embody. The original AMR26 concept was likely optimized around theoretical Honda data that never materialized in reality, forcing the team into reactive redesigns that sacrificed performance potential just to make the car functional. So, where does that leave the 2026 campaign right now? It leaves the team operating in survival mode rather than competition mode, using every remaining race as a data-gathering exercise for next year's clean sheet design rather than chasing championship points that are mathematically out of reach. Newey noted that serious work on the current car didn't begin until April 2025, meaning the team lost critical preseason integration time that could have identified these packaging conflicts before they became trackside emergencies. That late start created a compressed development window where engineers had to solve vibration, cooling, and aerodynamic problems simultaneously instead of sequentially, guaranteeing that none of those issues would receive the focused attention needed for proper resolution. The cascading effect is visible in every aspect of the car's behavior, from the hybrid battery failures to the steering feedback Alonso experienced. Because all of those symptoms trace back to a power unit that forced the chassis into compromises it was never designed to accommodate. Remember how this all started, with Fernando Alonso having to release the steering wheel mid-corner at the Chinese Grand Prix because the vibration was so severe it made the car physically dangerous to drive. That single moment wasn't just a driver safety incident, it was the visible symptom of exactly this packaging incompatibility, the point where theoretical engineering failures became tangible human consequences. The vibration that forced Alonso to let go wasn't random mechanical noise. It was the direct result of an engine installation that couldn't be properly isolated from the monocoque because the original chassis architecture had been built around assumptions that the real-world Honda unit contradicted. Every time the team tried to stiffen mounts or adjust damping to cure the oscillation, they were treating symptoms rather than causes, because the root problem was geometric and architectural rather than tunable. That's why Newey's admission about changing the whole car matters so much. It confirms that no amount of setup refinement could have solved what was fundamentally a design phase failure, and that the only true fix requires starting over with the 2027 regulations as a blank canvas. That 3.5-second qualifying deficit proves chassis flaws share equal blame. Even with perfect power, the AMR26 lacks fundamental aerodynamic efficiency. Wind tunnel correlation failed to predict real-world downforce levels accurately. Setup changes that worked in simulation produced nothing on track. Engineers chased phantom performance gains for months. The car's mechanical platform cannot generate sufficient load. Aerodynamic concepts broke down outside controlled testing environments. Tire management suffered from unpredictable balance shifts. Drivers reported inconsistent handling characteristics across different circuits. Development resources were wasted validating incorrect assumptions. The team's simulation tools require complete recalibration before 2027. Without accurate modeling, next year's clean sheet design risks repeating identical mistakes. Honda's vibration crisis masked deeper structural problems within the organization.